And the next one is PLDs, Programmable Logic Devices. So why we need programmable logic devices? The name itself, it is indicating programmable means it can be programmed at any instant of time. So I have one device which will support to implement any one of the logic, and that logic should be programmable at any cost of time. That's PLDs, Programmable Logic Devices. And it has the special functions like only this PLDs can be done device to device interfacing. Without PLD, we can't able to interface. Either it may be a microcontroller or it may be a microprocessors. And data communications. So when you are talking about of any one of the data, it needs one storage device. At least one bit. If it is one bit also, it is either it may be, latch will not store anything. So flip-flop will store one bit of data. Even this flip-flop also consisting of gates only. Again, PLD, logic device. Logic devices. Without logic devices, I can't able to manufacture one flip-flop, and without one flip-flop, I can't able to store one bit of data. And next one is signal processing. Means again, signal is just like data, whether it may be in terms of analog or it may be in terms of digital. If it is an analog, we will go for quantization and sampling, and then it will come to digital, again bits in terms of. Next one is data display, just like a digital display. In your mobiles, display is there, na? The same, whether it may be analog, like your old songs, and whether it may be digital, either it may be in terms of songs, or it may be a speech recording, or it may be a voice, whichever it may be the data, it can display. And next one is timing operations. What are the timing operations? For example, I need to execute one program after 2 seconds. So timer will fix this 2 seconds time, and an instruction will execute at 2 seconds time. And my question is, where the timing operations are related to PLDs. Once you fix the time as 2 seconds, then that particular register's location, let it may be 1, 2, 3, 4 location numbers. So once you fix the time as 2 seconds, up to that extent location 1 will not allow any data to insert the register. After completion of 2 seconds only, it will allow the data. There, the timing operations. And control operations means, once you fix the time, you already know. Control registers, which will control the entire operation of your program. So those control registers will take care of by using timing operations. And I have 2 examples over here itself for PLDs, most important and which are having drastic growth in nowadays. First one is FPGA, Field Programmable Gate Array, and CPLD, Complex Programmable Logic Devices. So next, general PLDs, next flip-flops, next gates, next passive or active elements. So passive and active elements means we already having our analog devices like resistors, capacitors, inductors, passive elements, and active elements are operation amplifiers or diodes or transistors like that. By using that only, you can generate any one of the gate. So by using some of the gates, you can generate one flip-flop. By using some combination circuits, you can generate PLDs. If it is a sum of PLDs, it will come complex programmable logic devices. And by using entire CPLDs and PLDs, you can generate FPGA, Field Programmable gate array. So why we need to implement like this? Only two purposes. The first one is logic density. By using gates, we can store 1 bit of data only. But if I want to store more number of data, then I have to calculate, or else I have to use more number of gates. That's what exactly that I have done in FPGA also. To store more number of data at the same time logics also. And the second one is high performance. So if it is a single gate, it can take 1 second only to perform. But by using one gate, we can execute only one operation. But if it is FPGA, it is also taken maybe 2 to 3 seconds of time, 3 seconds of time. But still it can execute plenty number of applications in that particular 3 seconds. Plenty number of operations. And these FPGA vendors are Vertex. Means Vertex will manufacture the FPGA kits. If it is a CPLD, why we need to CPLD? Only logic up to 10,000 gates. That is nothing but here, if we are using 10 gates in flip-flops, if it is in PLDs, we are using 100 gates. If it is CPLD, it is 10K of gates, 10,000 of gates. And this CPLD can be tested or can be simulated by using cool runners. It's a software. And while we are comparing with FPGA, CPLD number of consisting gates are, having FPGA, it may having 10 million of transistors, let it may be. So if it is a CPLD, it is having maximum of 10K number of transistors. Obviously, when you are comparing CPLD and FPGA, more number of gates are available with FPGA only. Hence, it will take more power to execute any one of the operation while we are comparing with CPLD. Because the number of gates available with CPLD is lesser than FPGA. Thank you.